In this video, I'm going to show you how to solve one- and two-step equations. So let's go ahead and get started. So first of all, let's start with a little intro. If I say solve x plus 3 equals 5, first of all, this is an equation because it's got an equal sign in it. And the question is, what am I asking you to find? Well, when you solve an equation, you're looking for a value for the variable, in this case x, that if you substitute it in, it makes the equation true. So in this problem, the solution is 2. So we call that the solution because 2 plus 3 is 5. So 2 is the value that makes this equation true. Another way that we say this sometimes is that 2 satisfies the equation. Normally we'll just call it our answer the solution. Alright, so I'm going to give you some equations to solve. And I don't care how you solve them, I just want you to see if you can solve all 6 of these. So stop the video, see how many you can do, and then check your answers. Alright, so let's go ahead and look at this. So on number 1, we're looking for a number that you add to 4, and you get negative 6. Well, let's see, negative 10 plus 4 would be negative 6. So if you know your integers pretty well, this shouldn't be too bad, but that may be a little bit more difficult if you are a little rusty. Let's see, on this next one here, we need some number minus 4 that gives us negative 3, and that would be 1. 1 minus 4 would be negative 3. On number 3, we're looking for some number. First of all, negative 3 next to x means negative 3 times x. So we're looking for a number times negative 3 that gives us 24, and that would be negative 8. On number 4, if you're not careful, you may have rushed and you got 2 out of this, but think about this. 2 divided by 4, or 2 over 4 is not 8. It would have to be 32. On number 5, this is one that you may have had a problem with because it's not a nice whole number. In fact, you should have gotten 5 halves, or you could have said 2.5 or 2.5, but 5 halves is perfectly good. And then on this last one, probably the hardest one for most people, you should have gotten 9. All right, so now I'm gonna see. Here's the thing: as the equations get more difficult in algebra, we need to have some equation solving skills, because in the beginning equations we can maybe do in our head quite easily, like especially the first couple there. But as things get more difficult, we're going to need some skills, and so I'm going to show you an approach that we'll be using in class. So the first thing I need to do is erase all these answers I just put in, and then we'll get started. All right, so first of all, our goal when we use this approach, and this is a pretty common approach, is going to be to isolate the variable, or most of the time our variable is x. We just want to get x all alone or by itself. So that's our goal. And in doing that, we're going to use 2 principles. The first principle is whatever you do to one side, that means add, subtract, multiply, or divide, must be done to the other side. And the other principle is what I call the principle of opposites, or the rule of opposites. So let's look at number 1. I'm not thinking, what do I add to 4 to get negative 6? I'm thinking, how do I get rid of the 4 so I can get x by itself? So the opposite of adding 4, because that's a plus 4, would be subtracting 4. And so I'm going to subtract 4 on both sides. Now notice that this is going to accomplish what I wanted, because 4 and a minus 4 add up to 0, and we're going to be left with x on the left. Now again, we got to add negative 4 to the other side, or subtract 4 on the other side. Over there we're going to get negative 10. And so by adding negative 4 to both sides, we're able to solve this equation. On number 2, I got to get rid of that minus 4 to get x by itself. So I'm going to need to add 4 to both sides, because a minus 4 and a plus 4, that's going to add up to 0, and I'll be left with x. And on the other side, 4 to minus 3 is 1. Now, you may not like the x on that side. With equations, it really doesn't matter. We probably usually put it on the left, but it's perfectly fine and true if x is on the right. If two things are equal, it doesn't matter which side they're on. Let's look at number 3. So, first of all, actually, let me go back here. Sometimes students will add 3 to both sides here. The problem with that is this is negative 3 times x. And so if I want to get rid of that negative 3, the opposite of multiplying by negative 3 is dividing by negative 3. So I need to divide each side by negative 3. Notice I'm using a fraction bar to do this, so it looks a little different than the last 2 problems we did. Now notice on the left, negative 3 over negative 3, any number over itself is going to be 1, so I can write 1x or just x. And then on the other side, I'm going to get negative 8 just by dividing. Now I want to point something out here. With all these problems, we can easily check our answers. With equations, that's always true. So I'm going to put a note here, check answers. In this problem, notice negative 3 times our solution, negative 8, does equal 24. So again, this is easy to check. We can do that with any of these problems. All right, so on number 4, let's see, we have division by 4, so we'll do the opposite and multiply each side by 4. X over 4 means x divided by 4. That's why we're multiplying, doing the opposite on each side. When we multiply fractions, we multiply across. So we'll have 4x over 4 on the left, and on the other side we get 32. Now 4 over 4 is just 1, so we're left with 1x or x. Now keep in mind, we could have actually canceled the 4's on the first line, and you would get x over 1 or just x. So really this step here is kind of an optional step. If it helps to write that step, I would encourage you to do it, but it's not really necessary. All right, number 5, let's see, we got 2 times x, so the opposite of, again, we're trying to get rid of the 2. So the opposite of multiplying by 2 would be dividing by 2. And so we're going to be left with x on the left, and on the right, you could think of it as 5 divided by 2, but it's also 5 halves. So let's just write it as 5 halves. There's no reason to change this to a decimal or a mixed number. You can leave it just like that. Even though it's an improper fraction, it is considered simplified. All right, last one, number 6. Well, let's see, we could divide both sides by 2/3 since we have 2/3 times x. But when we divide by a fraction, we end up multiplying by the reciprocal. So there's a little bit easier approach here. The thing is, I'm trying to figure out, is there something I can do to 2/3 x, or 2/3, to get 1? And if I multiply by the reciprocal, 3 over 2, whoops, I forgot to put that in, 3 over 2 here, well, notice that's 6 over 6, which is 1. So when we multiply by the reciprocal, we get 1, which is what we want. We want a 1x or just x. Of course, whatever we do to one side, we've got to do to the other. And be careful here. Let's go ahead and write this as 6 over 1. We want to multiply our numerators and multiply our denominators. We get 18 over 2, and so we're going to get 9. All right, so let's move on to the next page. Oh, one last thing. These are what we call one-step equations. The reason why is because it only took us one step. We did one thing to both sides, and we got x by itself. All right, let's move on to two-step equations. Oh, I'm sorry, before we do that, I do have 4 problems I want you to do. So go ahead and try these, and then we will move on to two-step equations. All right, so on the first one, you should have multiplied each side by -5. Notice the -5's cancel. You get x equals -50. On number 2, I'm trying to get rid of the 4 so I can get x by itself. I divide each side by 4, and so I'm going to end up with x equals -15 over 4. Now, if you put the x on the other side, that's fine. It doesn't matter which side it's on. And 15 over 4, again, is a perfectly good number. There's no reason to change that to any other form. Let's look at number 3. Notice a minus in front of x is really a negative 1x. There's no number written there. It's understood that there's 1x there. So we really have negative 1 times x. We want to divide by negative 1 on both sides. Of course, a negative divided, well, negative 1 over itself is just going to be 1, or 1x. And on the other side, 4 divided by negative 1 is negative 4. On number 4, let's get rid of that 2 by subtracting 2 on both sides. And then we're going to get x equals negative 7. All right, so now we're ready for two-step equations. Oh, one last thing. On number 4, again, I would remind you, notice here I plugged in my negative 7 solution, and you can see that it does check, it does work. All right, now we're going to solve two-step equations. So I want to start with this problem here. Now, the first thing I want to point out is, first of all, can you see why this is a two-step equation, or why I call it that? Notice I'm going to have to get x by itself, that's my goal. I'm going to have to divide by 2, and I'm going to have to add 7. So the question is, which one do you do first? Now, if you think in terms of order of operations, you might be thinking you need to divide, but we're solving equations. It's not like doing an order of operations problem. So what if you did divide by 2? You have to divide the whole side by 2. And we would do the same thing to the other side. And I don't know about you, but I look at that and I'm thinking, that doesn't look like such a good idea. So let's maybe not do that. And so let's try adding 7 to both sides first. So when we do that, notice the 7s are going to be adding up to 0 here, and so we're just going to be left with 2x. On the other side we get 16. And then you can either do that in your head, or you can just divide each side by 2 to get that x by itself. And we're going to get x equals 8. And we can check this. I'm going to go ahead and rewrite the equation, but where you see the x, I'm going to put parentheses, and let's plug in our 8. And notice 16 minus 7 does equal 9, so when you plug in 8, it does make this equation true. And so as I said before, we can check these, very easy to do. The other thing I want to make a comment about is what we just talked about a minute ago. With two-step equations, we're always going to add or subtract first on each side, and then we'll multiply or divide. In this case, we added 7 to each side first and then divided second. We'll always multiply or divide last with these, add or subtract first. All right, so I think we got 4 I'd like you to do. See if you can do like I did on the one that we just talked about. And so do as many of these as you can, and then restart the video and you can see how you did. All right, so let's look at number 1. We know we're trying to get x by itself. We got to get rid of the 3 by dividing, and we got to get rid of the 4 by subtracting 4. And we know we always add or subtract first, so let's subtract 4 on each side. And that's going to leave us with 3x equals 15. And I think we can do that one in our head. I don't see a problem with that. You can show division by 3 on both sides if you want, but this is going to be 5. Now on number 2, again, don't worry about x being on the other side. If we wanted to, we could rewrite this as 12x minus 4 is equal to negative 10 with the 12x minus 4 on the left, but we don't have to do that. Let's see, we got to get rid of the 12 and the minus 4 to get x by itself, so we're always going to add or subtract first. So notice the 4's cancel there, the minus 4 and the plus 4. We're left with 12x on the right, and on the left we'll get negative 6. Now be careful here. If you go too fast, you might think the answer here is negative 2. But again, we're trying to get the 12 by itself, so let's divide by 12. And so we actually get negative 1/2, not negative 2, or 2. All right, number 3. This one's a little bit tricky because you see that minus there, and you might be thinking you need to add 5 to both sides to get rid of that 5. But in fact, again, it's mainly because these, the 5 and the x are in the opposite order of what we're used to seeing. Think about this though, if we have a positive 5 on the left side, the only way to get rid of that term is to subtract 5 over there. So if we subtract 5, 5 and a minus 5 does give us 0. Now be careful, what we're left with is a minus x. And on the other side, negative 3 and negative 5 is negative 8. Now remember, this is negative 1 times x, and so to get rid of the negative 1, we'll divide each side by negative 1. By the way, you could have also multiplied both sides by negative 1, and that will work too. Multiplying or dividing by negative 1, you get the same answer. So we're going to end up with x equals 8. Last one. Now I know some of you saw this and you saw the fractions and you were afraid, but it's not so bad. Again, we have division by 4 and subtraction of 8. And so we're going to do the addition or subtraction first. So we'll add 3 to both sides. So that's going to get rid of the 3 there. And we'll be left with x over 4 equals 12. And we did a problem like this just a few minutes ago. We have division by 4. We got to get rid of that 4. So we do the opposite and multiply by 4. And we're going to get x equals 48. And that's the end of this video.